This is Metal Mechanism Expanding Table, Part 1. So first I'd like to thank all the people who have followed up and emailed and kept me honest on my commitment to build this version of the metal table. So thank you. It's been really nice to get that continued interest in the email saying, hey, are you going to do it yet? So yes, I'm doing it right now. The next question, of course, is why build this version? Because I already have a Metal Mechanism Expanding Table. Why do I need another one? And there's a couple reasons for that. The main one is accessibility. This one, I had a lot of fun learning TIG welding and machining these inner parts and finding the bearings and doing all of that, but it took a lot of work and it requires specialized tools. So I want to make it more accessible. I also want to, and so I do that by using more generic tools. So the goal for this one is to require only, as far as metal is required, basically an angle grinder and a MIG welder. Other than that, it'll be hand tools, ratchets, things like that, but nothing like a lathe or a mill, although they might be helpful. The second reason why I want to build this one is to incorporate customer feedback. So I've gotten quite a few requests from people, and the most common one by far is to have a larger size. So I'm going to be looking at a 5-foot diameter versus a 4 on the previous one when it's in its small state. I'm not sure exactly what it'll go up to in the larger one. We'll determine that. But 5 foot is a good size. If you go too much bigger, it becomes hard to reach the center when it's expanded. And it's also pretty close to 1.5 meters, which is a nice round figure for my international audience. And they make up, depending on the month, more than half the people who visit my site. So that's really cool. In order to make it accessible, we need to not only have accessible tools like these, but we need to have parts which are accessible. And they need to be accessible to people everywhere. With that international audience, or even a national one, I can't just say, hey, there's a place down the street where you can get a great deal on this part. That's not going to work. I need something that's not just in the US, but available everywhere. And that's where we're relying on more generic components like shafts and in the wood table version, a Lazy Susan. Everybody has that. Cabinets all over the world use that. So that's a really good globally available component to use. What I have done for this metal one is to focus on getting some of those core mechanisms that took a lot of work here and find them in other ways. As an exclamation point on my commitment to using simple tools, I actually took my mill off of its temporarily permanent stand that I had with the sawhorses and put it down on the floor and over in the corner where it's not quite unusable but much more awkward because I don't want to have to use it for this project. Since we're on the hunt for a mechanism that comes in a pre-built assembly, I thought it'd be good real quick to review what it is that we're looking for in our mechanism. Most important thing, obviously, is that it has to go around. And then with an expanding table, it obviously has to expand. If you don't have that, that's no good. And it has to go up and down by 2 different amounts. These intermediate ones, which are over there somewhere, go up by 1 whatever unit. In my case, it's about 1 inch. And then the star that's in the center has to go up by 2x that amount, or 2 inches. So those are the things that we're looking for. And the most core motion, the one which has to be absolutely the best, the most locked down and have as little play as possible, is the rotation, because everything rides on this shaft. Whatever play you have in here is going to stack up into the other parts, and being in the center and on a narrow shaft, it's also going to get exaggerated just due to the leverage difference here. So that thing has got to be fantastic. And I was looking around, literally the world, trying to figure out where I could find this motion, like some rotation that's pre-built, that's available all over the place. And I was thinking about cars, because when you change the tires in your car, for example, or rotate them or do whatever, you'll have it jacked up, you get the tire on there. I mean, there's virtually no play in that wheel bearing. It's pretty big. It's designed to take a lot of force, and they're all over the world. So the problem with a regular car setup or wheel bearing is that they're designed to mount to the A-arms or the control arms and all that stuff. If it's for the front, it has the steering mechanisms on there. It's very complicated to interface to. But I like the bearing setup and all of that. Then I started to think about trailers. Because trailers are set up, they're all over the world first of all, they're just like a tire, like I was talking about for the car, and they have the taper bearings with the preload and all that sort of thing. They're available in kits. You can buy just those parts. You can use them for a lot of things. They come in different mounting setups. You can buy the entire axle, which then mounts to some suspension. You can buy just stubs that you weld on. And so I looked around and I looked around. There was a little bit of an extra caveat on this, which is that if you look at the rough dimensions here of 8 inches in diameter and then 10 or whatever it is on the height here, that doesn't really look like any rim that you're going to find out there in the market. It's also straight. I have never seen a straight rim unless it was something very, very specialized. So I had to shop around a little bit to find a combination that would suit what I wanted. And I think I found something pretty good. So let me pull it up here. First I gotta move this bad boy, which never gets any lighter. So number one, we need to be able to mount this whole thing to some sort of block like that table is. And if you have just the spindle, someone could obviously weld that, but if it comes with a flange that's already welded on there, it's professional, it's designed to hold 1,800 pounds, I believe in this case. That's all the better. It even comes with the holes made in it. So, take my spindle. It's not going to be especially solid in this vise because the vise comes together like this and it can rock. But anyway, we've got our spindle, we've got our plates, we can screw it down. Okay, awesome. Now, we have our set of roller bearings, which by the way, or taper bearings rather, they also have rollers in them. It just slips right on there. I mean, that is so incredibly easy. You buy the corresponding hub that goes with it. Drop that on there. Put our other taper bearing. There we go. So there's no preload on this right now. And even with just a finger preload, there's virtually no play on that. If I did it properly with a wrench, obviously you could get it dialed in. So that's pretty neat. This hub here, or rim, is actually for a utility trailer. Hence, its more boxy nature. So I take this guy and drop it on there. We'll just pretend that they're on. And this thing is rock solid. It's well designed, it's got the flanges welded on there, you can control your preload. It all comes pre-designed. This thing delivered was, I believe, $120. The amount of effort that I had to put in to reconstruct this basic mechanism on that thing, now I was getting exactly what I wanted in terms of dimensions and everything, but man, for someone who wants to look at building this on their own, this, just showing up and fastening it together, is a much more compelling option. Now attaching to this rim is obviously going to be a little bit more difficult. It is powder coated, so we're going to have to grind that off. But you could weld either a plate and then fasten to that with hardware, or we could weld directly to this. I haven't quite determined that. This is something we're going to get to in a minute, but I have not fully fleshed out the plan here. I have some pretty good ideas and things I've been thinking about, but this is very much a work in progress, hence the series and not me just showing you the result. So this is our main hub. It's very solid if I run the screws down all the way. And this is going to form the basis of our mechanism. So once we have this, we then need to start getting a feel for how large our table is that we're talking about. And this guy is 54 inches across. So the arms that we're going to have are not going to be the full size of the actual table, because that has to overhang and do other things. This is 6 inches under, that's 3 per side, so it could be a little bit bigger than this. But basically we're looking for 27 on the center. This is giving us a good idea of how big our arms are going to be. And the fact that this hub diameter, which I believe is 11 inches on the outside, is roughly proportionally larger than this one in the same way that the overall size is. That didn't come out very eloquently, but I think you know what I mean. Basically everything has grown approximately proportionally in terms of these dimensions here in this plane. So that's pretty good. It feels about right. You look at the overhang, you could feel that this would be stiff enough to be used and for the user to be satisfied. We also end up with a little bit of a conundrum in terms of our ability to expand this table. The key point to keep in mind in terms of the expansion ratio is that if you were to use an arm system, your maximum expansion is the diameter of where those arms are mounted. So if these arms, if this is the arm which is going to push it out and it's mounted here, this from here to here is the maximum expansion that it can offer, because it came from this side over to here. And so in this case, if I use an 11-inch diameter, I can only have 11 inches of travel. And if I want to expand this table to account for this 5-foot diameter and then have a certain percentage, I have to allow for that. But when I have this increased diameter here to potentially allow more expansion, I'm also restricting my ability of those carts to slide back and forth and have that travel, right? So by expanding this ratio, you increase your expansion, which requires more travel, but you also start to take over some of that area where the cart is going to travel. And then likewise on the outside, if you start running into boundaries with the skirt, which is out here, and that cart ends up being relatively narrow or short, whereas you want it long for stability. So these are some of the things which are floating around in my mind that I have to take into account. Speaking of slides, it's very compelling to look at these linear type slides, which go back and forth. They're very tight on the rails. They have very little play. I mean, they seem like the perfect option. In this case, I went with these much larger ones in the previous version. And then the other probably obvious choice would be, if I can locate it, to use a drawer slide. And so the drawer slide has the obvious problem of being too deep right here. Vertical height is our most scarce resource on this table. And this guy takes up too much. It also has too much play, especially in this direction. You could potentially work with that by having one on each side, but in any case, drawer slides are a no-go. These guys tend to get kind of costly, and they're also fairly narrow. And that's an issue because I need stability side to side. Keep in mind that these panels are going to be very wide, and this little tiny thing, even if it was super tight, it's just going to have flex. So these are out for right now. The cost and accessibility also is something of a concern, mainly the cost and the performance. I guess they're all about equal. Suffice it to say, these are great for many things. I don't feel that they're the right solution for this. This type of cart, this one happens to be wood because I didn't want to make it out of aluminum at the time. And I have my 3-point adjustment system. But this, whoops, speaking of travel limitations, this system right here, these are aluminum rails, they've been anodized. It has bearings. I have a little bit of a flexure going on here so that it keeps it tight, but isn't so tight that if it hits any type of debris, it would jam up. This system just works pretty well. It's much, much wider. It's probably 3 or 4x the width of that linear rail. And I think right now I'm going to stick with a system like this because it has more control. It's very easily and compactly mounted to whatever material we want to use for our arm, which is probably going to be steel in this case. And I just like it. It gives me a lot of flexibility. It also leaves this height in the center, not just the height, but the width, open and available for some other mechanisms that I've been thinking about to move it back and forth. So we're going to be sticking with this for right now. For the vertical system, the raising and lowering, I'm going to stick with ramps just like I had on this one. It seemed to be a pretty good system. It's super reliable. It provides a direct path for the force on the lifting ones to go down into the plate. And it's dead simple. So we're sticking with that. These vertical guides, on the other hand, I'm not quite sure are going to work for this mechanism. It required a lot of welding to put all this together, and there's set screws to adjust these to make sure they're tight. And right now I'm thinking of a very similar system in terms of having 4 spots and it's constrained, but I'm thinking about using shafting, maybe 12mm or 8mm shafting, something like that for these verticals, and then more of maybe a slider or something which traps it. So kind of a similar concept, but a different implementation to try and make it easier and just prevent all of this fastening together. I want to talk more about this expansion mechanism because this is what has been occupying most of my free mental capacity lately. So this hub here does the rotation, and that's great. what we need is a stationary piece in the center that does not move with the hub, because the arms are moving. By these arms, I mean. And then the expansion arms attach to this, and when this goes around, it forces the cart out, okay? And so the problem here is that we need this stationary piece right smack in the middle of a bunch of things that are moving. Keep in mind that star has to sit on top of here, and that has to move too. So we end up with these little pieces right there, and those are just connecting it so that they can leave open these slots for the arms which track and raise and lower the star mechanism. So we have this problem where we have all these parts that need to rotate and do sorts of different things, and we have this big piece which needs to not do anything and stay here in the center. And this is a problem. And not only is it in an awkward spot in the middle of all this, it's also right where we are, we care a lot about all of our vertical stack and how much distance we're using here. So this piece, if I could avoid this piece, that would be great. And I've been thinking about this because I have some ideas. These arms also have to wrap together. You'll probably recall that I stagger these. I put some on top and some on bottom, and that is so that they can wrap more tightly. Otherwise you have to get the pattern just right. Also, you'll notice on some of these, you know, this has been ground down here to get clearance for the arm. These carts and then the panels have to hang over this. So I think I've made my point, which is that this part is necessary, or this function is necessary, but this part drives me nuts because it takes up a lot of space in a location where I don't have it, and it also has a very tenuous mount because the only part here which isn't moving is this spindle, and I have an additional difficulty here, which is that this spindle, keep in mind that wasn't fastened down, it doesn't have as good of a flat face on it. I was able to machine this and do some other things to get a nice mounting face here, and I'm not going to have that. And in keeping with accessibility, I can't just tell people, hey, go machine a special castle nut and, you know, cut some threads on it, right? That's not going to work. So what I'm thinking is that if I can take this mechanism, this flat part, and shift it down lower, that would be fantastic. Because down here, I have this giant flat plate that doesn't move, and I have this flange plate, which is a little higher up, but whatever, and that's not moving. And I also have access to everything below. I've got all kinds of room for things that aren't moving. This would be a great place to have that plate. But the problem with down here, of course, is that the pushing action that I need to transmit is for parts which are on the top up here. And I can't just reach out with an angled piece like this, because then that'll have to travel out. It's going to bump into the person's knees. That's not going to work. I thought about having some mechanisms like this, which as they go up, do that. No dice there. You could have some sort of lever mechanism where it rides against a profile on the inside. But then there's a piece here, there's a pivoting piece here, and then another one there. You also have to get the ratios right so that the leverage is correct. It starts to get complicated, and then you have all the play in your pins, and that stuff stacks up, and then they don't come together correctly. So what I need is a way to do this expansion motion down low and get it up high. I haven't actually figured out how to make this work in its entirety yet, but the idea of using cables is very enticing because cables could be attached at the bottom, you could have your motion take place, and they can get routed in all sorts of funny directions and through cavities and all sorts of other things in order to have this motion out here. So the problem with cables is that they have some stretch, they have some other issues, they can only be used mainly in tension. There are push cables, but the problem with push cables is that they tend to be for short displacement. So if I need to displace this thing by 10 inches, a cable which could extend 10 inches past its housing is probably going to be pretty stiff and won't be able to bend around the kind of radius that I need. So I'm not seeing that as a super viable option unless I levered it up or geared it up somehow, in which case it's getting complicated again. So I don't want to do that. I think that one's to rest. So we're looking at cables and tension. So what we have here is the hub, which is attached to the arm, and that's going to rotate, but these points where the cable is anchored are fixed. And so if we were to move this arm around, this cable is going to sort of circulate around here. So this is a fitting which is on the cable, and as I move this way, the fitting is going to end up going around. Another maybe better way to describe it is that our cable, which we have here, is going to stay in place. It's fixed. We have our fitting on the end here. And as I move this arm, when that cable stays in place, this thing is going to translate in and out relative to the arm. And so if we started here, it's going to go out, 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 and then as I go over center, it's going to start to come back in. And that's the motion that we're looking for. The other very important benefit to this, which is maybe not so obvious, is that you can control this diameter. And by controlling that diameter, you can control how much cable circulates and how much extension you're going to get out of your mechanism. Better yet, instead of our expansion being controlled just by the diameter of the mounting points, which gives you this much maximum expansion, this is actually controlled by the circumference because we're wrapping around it, which means that now we can get the original amount of expansion in only this much angular travel, or in the same amount we can get pi over 2 more, or 57% more travel. That's a big increase. We may not need it, but we could also shrink an equivalent system inward. So without impeding a very large space here, you could still have a large expansion ratio on top and allow your carts to have this much track, this much additional track to come in. That may not look like a lot, but I mean, this right here is 10% more, right? And when you're talking about stiffness, 10%, things get squared and all of that. I'm doing some hand waving right now, but I'm just saying in my experience, having even a little bit more length, very helpful. And especially, having it on this side, you could go to 2 wheels on each side instead of just 3. Anyway, I'm excited about it. The stretch issue doesn't concern me too much because if you choose the right cable and you put the proper load on it, you can have a spring over here to maintain tension. And if each cable is independent, then you can just adjust them so that they sync up at the beginning. In general, I feel pretty good about the cable. A lot of the issues that could be introduced, I feel like, are outweighed by its benefits. There are some finer points on this, like you want to make sure that your travel in the direction which is most likely to receive high force, like someone pulling out, for example, on the panel, is going to be against the hard point that's anchored so that it wouldn't have any spring. Because you don't want to have a super stiff spring over here. Stiff enough to keep the slack out. I mean, that's its purpose, but you want the main motion to be against a hard stop if you can. Obviously, it's going to have to be some against here, but we want to prioritize there. The downside to this system, and this is sort of the sticking point that I haven't 100% figured out, is that we need to change direction. So this thing is going to continue sweeping around, and I need this fitting, for example, to circulate. I need it to go this way and then to start coming the other way in order to pull the thing back in. So this could go around like that, meaning it's continuing in one path but is now changing direction this way. I mean, obviously I've thought about this quite a bit, and setting it up in this orientation is something that I've thought about quite a bit. You could also do it vertically, you could have some other setups, but anchoring this very solidly to this cart and then having it change where it is this way is something that I'm thinking about a lot, and I'm trying to decide if the downsides of this are going to be worth it. I feel very strongly that freeing up this area here will be a major benefit. It'll make it so much simpler for people to build in terms of needing to, access to this space down here, which, keep in mind, is not nearly as deep on this one, so we'll have to have a little bit of creativity there. It just opens things up, though. So I'm feeling optimistic about the cable thing, but it needs some serious experimentation. Right now, I do have some 27 thousandths cable. This is actually fishing leader wire, 7x7. And at 27 thousandths of an inch, it's rated for 90 pounds. That's the test rating on this. You know, we can size the cable appropriately to get the strength that we need, the limited stretch, and also the bend radius, because this cable is going to have to be anchored, come around, go like that, and then back down. The other thing about using a cable in tension like this is that it stays wrapped around this drum here. There's a lot of these ideas that have been floating around. I'm just throwing them in as I can. I try to organize it, but sometimes, you know, it doesn't work perfectly. So even if you were to use a push cable, which had the 10 inches of extension that you need, 10 is just an estimate right now, it's not going to wrap around here, right? You're sort of pre-buckling it. So if you started trying to push it around a curve and it's exposed from its housing, it's going to want to buckle this way. So that's another reason why I wasn't feeling that great about the push cable. But a cable under tension, if this is under tension, that'll stay wrapped. This will redirect. I feel like there's a lot of benefits to this cable thing. And the reason why I'm jumping to this expansion mechanism is that, first of all, it's obviously central, you know, physically and philosophically to the table, but it also changes everything, because if this space can become free, then our tracks become longer, like I mentioned. Our height sort of balance changes in terms of where things are. So I need to figure out what my plan is for this. If I'm going to stick with this current one, then I kind of know what I'm dealing with, and that's fine. We'll figure out a way to make it happen. If I could shift some of that mechanism down, it would really open up our possibilities here. And even if we kept things very similar, it would just reduce the space constraint, so that when people build it, it won't matter so much if their screw's a hair too long or whatever. You won't have to take it apart and grind it off in order to get this clearance. It'll be okay. It makes it easier. That's something that we need when we go from design to production, is to allow wiggle room for reality to show up and intrude and make things go wrong. Another cable strategy which seems promising at first is to set the cable up so that it's wound and that the rotation unwinds it, and when it goes over center, it changes direction and begins to pull it back in. This is really emulating what's going on with the solid arms, but doing it while keeping the cable in tension. And the difficulty that I see with this approach is that you have to maintain this tension over here, and you are relying on that tension to expand the table. So you're going to need a spring which has 10 inches of travel. I'm ballparking 10 inches as the travel right now. And it's going to need to have that. The force is going to, unless that spring is very long, your force is going to change quite dramatically over that length of travel. You have to contain that spring somewhere. If you've ever seen garage springs, which are long and have a lot of travel, they tend to creak and things and rotate a little bit and make noise, which then translates through the whole thing. I know this video is a little heavy on the strategy and philosophy of the table, but I think it's important to lay it out there and make sure that for the people who are interested, that they understand really what's going on and why I'm pursuing a particular direction and all of that. But in video number 2, we're going to have a lot more action. We'll make some wood chips and maybe some metal chips and all that. And we'll take some of my ideas about the cable and other things out to meet reality and find out which ones need to go on the shelf with all the other good ideas that I've had for previous projects. So I look forward to it, and thank you for watching.